Hello and welcome dear student, this is Chandrakant here and today's topic is quadratic equation. So let's see some definition of quadratic expression and definition of quadratic equation and its roots. First of all, we will see that in the quadratic expression. What is the quadratic expression? It means quadratic polynomial, and quadratic polynomial it means degree 2. It means degree 2. And what is the polynomial? So let's see the definition of polynomial. A function f of x is defined by a function f of x is defined by f of x equal to an x raised to an minus 1 x raised to n minus 1 plus an x plus a0, where an not equal to 0 and a0, a1, an belongs to real number. An belongs to real number and n belongs to whole number. This is n degree polynomial. If we put here an equal to 0, then this will become n minus 1 degree polynomial. And what is the quadratic polynomial? Quadratic polynomial it means degree 2. And degree 2, what is the meaning of degree 2? It means highest power of x will be 2. So this will be x square plus bx plus c, and where a not equal to 0 and a b c in real number. This is called quadratic expression. And f of x, let's see an example. F of x equal to 2x square plus 1. Here the coefficient of x b is 0, and but a should not be, the coefficient of x square should not be 0. So here a equal to 2 but b equal to 0, and this is also a quadratic expression. Now quadratic equation, and we know that quadratic expression it means f of x equal to x square plus bx plus c, and if we put f of x equal to 0, then this will become ax square plus bx plus c equal to 0, and where a not equal to 0, a, b and c belongs to real number. This is called quadratic equation. This is also general form of the quadratic equation. General form of a quadratic equation. Quadratic equation. Now, roots of a quadratic equation. Roots of a quadratic equation. Let's suppose we have the general form of a quadratic equation ax square plus bx plus c equal to 0. This is the general form of a quadratic equation, and where a not equal to 0. Now we have two methods to find out the root of a quadratic equation. First, factorize, and second, quadratic formula. Now let's see an example. X square minus 5x plus 6 equal to 0. Now we will find out any two value. If we add, then that should be minus 5, and if we multiply, then both numbers should be 6. So we have minus 2 and minus 3, and this will become x square minus 2x minus 3x plus 6 equal to 0. X will be common, so this will become x minus 2 into, and minus 3 will be common, then x minus 2 this equal to 0, and x minus 2 also will be common, and this will become x minus 2 into x minus 3 equal to 0. Now the roots of the quadratic equation, x equal to 2 and x equal to 3. So these are the root of a quadratic equation. Now what is the quadratic formula? We know that quadratic formula x equal to minus b plus minus root b square minus 4ac upon 2a, where b square minus 4ac denoted by d, and d is called discriminant. D is called discriminant. Now let's see an example. 5x square plus 6x plus 1 equal to 0. So how can we factorize? And we know that the general form of quadratic equation ax square plus bx plus c equal to 0, and we comparing both equations, then we will find a equal to 5 and b equal to 6 and c equal to 1. Then x will be, now we will put the value of a, b and c in the quadratic formula. So we will find x equal to minus b, it means b equal to 6 minus 6 plus minus b square, it means 6 square 36 minus 4 into a is 5 and b is 1. So now divide by 2 into a is 5. So x will become minus 6 plus minus 36 minus 20, this will be 16, and root of 16 is 4, and divide by 10. Now the value of x will be minus 1 by 5 and minus 1. So there will be two roots of a quadratic equation, x equal to minus 1 by 5 and x equal to minus 1. Now find the root of a quadratic equation. We can simplify it by the factorize. So we can factorize it by x square minus x minus 2x plus 2. How can we need two value? So if we add, then that should be minus 3, and if we multiply, then that should be plus 2. So if we factorize, then x minus 1 minus 2 x minus 1 equal to 0. X minus 1 will common and x minus 2 equal to 0. So here the roots of the quadratic equation, x equal to 1 and x equal to 2. Now let's see difference between equation and identity. Let's see the general form of the quadratic equation ax square plus bx plus c equal to 0, where a not equal to 0. If a not equal to 0, then there will be two roots. There will be two roots of this quadratic equation. There will be two roots. It may be real or it may be imaginary. And if a equal to 0, then this will become bx plus c equal to 0, and this is called linear equation. This is called linear equation. This is called linear equation, and the root of linear equation always 1. Root of linear equation always 1. And if a equal to 0, b equal to 0 and c not equal to 0, then there will be no root. Then there will be no root. If a equal to 0, b equal to 0 and c not equal to 0, then there will be no root. And if a equal to b equal to c equal to 0, then this will become an identity. Then this will become an identity. Then this will become an identity, and the roots of an identity are infinite. The roots of an identity are infinite. Any identity, there will be infinite roots of any identity. Let's see an example. X plus 1 e raised to 2 equal to x square plus 2x plus 1. If we put here x equal to 0, x equal to 1, x equal to minus 2, x equal to 3, we can put any value and this satisfies all the value. So we can say this is an identity. And what is the definition of an identity? Any quadratic equation which has more than two roots. We can say 3 or more than 3 roots. That is called an identity. So now relation between roots and coefficient. Relation between roots and coefficient. Let's see the general form of the quadratic equation ax square plus bx plus c equal to 0. Ax square plus bx plus c equal to 0, where a not equal to 0. Where a not equal to 0. So let's see, we have two roots, alpha and beta. Alpha and beta. So any quadratic equation which has two roots, alpha and beta, so this can be written as x minus alpha into x minus beta. And we know that a is not equal to 0. A is not equal to 0, so this can be written as x square minus alpha plus beta into x plus alpha into beta equal to 0. This is equation first. This is equation first, and we know that ax square plus bx plus c equal to 0, and divide by a to the complete equation, then this will become x square plus b upon a into x plus c upon a equal to 0. This is equation number 2. Now comparing both equations, then we will find out alpha plus beta equal to minus b upon a. Alpha plus beta equal to minus b upon a, and alpha into beta is c upon a. Alpha into beta is c upon a, and this can also written as minus coefficient of x divided by coefficient of x square, and this is also can be written as, this is constant term, this is c is constant term, so this can be written as constant term divided by coefficient of x square, coefficient of x square, and this is also sum of roots, and this is also product of roots, Now let's see an example. If alpha beta are the roots of the quadratic equation cx square minus 2bx plus 2a equal to 0, then find the quadratic equation whose roots are alpha by beta and beta by alpha. So we have the equation cx square minus 2bx plus 4a equal to 0. Here the roots of this quadratic equation alpha and beta. Now alpha plus beta equal to minus b upon a, alpha plus beta equal to minus b upon a, then this will become 2b upon c, and alpha into beta is c upon a, then this will become 4a upon c, this is minus b upon a, and this is c upon a. Now if we have the quadratic equation whose roots are alpha and beta, that can be written as x square minus alpha plus beta into x plus alpha into beta equal to 0. It means this is sum of roots, and this is product of roots. So we can written as the new quadratic equation x square minus sum of roots alpha plus alpha upon beta plus beta upon alpha into x plus alpha by beta into beta by alpha equal to 0. Now x square minus alpha square plus beta square upon alpha into beta into x, and this is 1 equal to 0. Now we have alpha plus beta and alpha into beta, so we can also find out alpha square plus beta square. So we know that an identity alpha square plus beta square equal to alpha plus beta raised to 2 minus 2 into alpha into beta. Now we will put the value of alpha plus beta, this is 2b upon c raised to 2 minus 2 into 4a upon c, and this will become 4b square minus 8a upon, and this is c square and this is c, and this will become 4b square minus 8ac. This will become 4b square minus 8ac upon c square. Now we can put the value of alpha square plus beta square, then this will become x square minus alpha square plus beta square is 4b square minus 8ac upon c square, and alpha into beta is 4a upon c, and multiply by x, this is 1 also. Now we will simplify here, c will be cancelled out and 4 will be cancelled out, this will be 2, and this is x square minus b square minus 2ac upon ac, multiply by x plus 1 equal to 0. Now multiply by x to the complete equation, then this will become ac x square minus b square minus 2ac, multiply by x into plus a into c equal to 0. This is the required result. Which is the required result? Now let's see another example. If alpha beta are the roots of the quadratic equation x square minus root 2x plus root 6 equal to 0, then find the quadratic equation whose roots are alpha square plus alpha square and beta square. So do it by yourself. Do it yourself. Now, nature of the roots. What is the nature of the roots? Let's suppose we have the quadratic equation ax square plus bx plus c equal to 0. Ax square plus bx plus c equal to 0. This is the general form of the quadratic equation where a not equal to 0, a, b and c belongs to real number. Now, we know that the quadratic formula x equal to minus b plus minus root b square minus 4ac upon 2a. 4ac upon 2a. And b square minus 4ac denoted by d. b square minus 4ac denoted by d. And this is called discriminant. This is called discriminant. This is called discriminant. Now, if d equal to 0, now if d equal to 0, if d equal to 0, then there will be two roots. There will be two equal roots. And what are the roots? X equal to minus b upon 2a. Equal and real root. Equal and real root. And if d not equal to 0, then there will be also two conditions, d greater than 0 and d less than 0. D less than 0. If d less than 0, then roots are imaginary. Then roots are imaginary. Then roots are imaginary. Then roots are imaginary. Let first root is p plus iota q. Then second root will be conjugate of p plus iota q. Then second root will be p minus iota q. Now, if d greater than 0, then there will be also two conditions. First, if d is perfect square, d is perfect square, then roots are rational. Roots are rational number. Roots are rational number. If d is not perfect square, d is not perfect square, d is not perfect square, then roots are irrational number. Then roots are irrational number. Roots are irrational number. Let's suppose first root is alpha equal to p plus root q, and then second root will be p minus root q. Sorry, beta equal to p minus root q. This is the nature of the roots, and rest of the topic we will see in the next video. Okay, thank you, bye.